everybody. Sorry I'm not here today. I'm at meetings at Borden. I'll be back tomorrow though. But today we're going to finish up lesson 3 out of module 6. So remember, we started lesson 3 on Friday, and here were our I can statements. We worked on writing a subtraction problem when we were given the real world problem, and then we worked on solving that subtraction equation, and we used our new property, the addition property of equality. So let's just do a really quick review here. So when I think of a subtraction problem, I'm getting a variable and I'm taking away a value and I'm equaling some other term. Okay, so remember on Friday we talked about what we already know about subtraction is subtraction means I have to start with my big, I take away a part, and that will give me another part. But if I already know my two parts, then to figure out my whole, I just put those parts back together. And that's where this addition property of equality comes in. Because instead of subtracting 33 to get x by itself, what I really want to do is add 33. So those will cancel out, and we'll have x equals whatever 112 plus 33 would give me. So I am going to work on adding this equation up. So I add up my ones column, add up my tens, add up my hundreds. So I end up with x equaling 145. Now I can always go back and check, because if I substitute 145 in for x and I subtract 33, I should get 112, one of my parts. So I'll subtract, do a real quick check here, and I get the answer. Okay, so remember, when we're talking subtraction, our whole value is what we're talking up front. Our part is what we've taken away, and a part is what we've ended with. Okay, so we use that addition property to go back and figure out that missing part, to put it back together to figure out what our whole is. All right? So today we're going to start on example 3. So you don't need your books out yet. We're going to work through this example 3 together and talk about it a little bit before you look at what your answer is and get to work on one on your own. So here's example 3. It says solve m minus 13 2/3 equals 2 1/3. So again, I think what I know about subtraction, I know my whole minus a part leaves me with a part. So if I put my parts back together, I'll end up with my whole value. Or using that addition property of equality, if I add 13 2/3 to both sides, this side will cancel out, leaving me with m. Add 13 2/3 to this side, and now is where I've run into a problem. So if you remember on your warm-up activity, as we were working through problems like this, we looked at if we're adding or subtracting fractions, they have to have common denominators. So the first thing I'm going to have to do is get common denominators for these. Or we talked about this on Thursday when you guys were in class. We said we could also make both of these an improper fraction, which meant we also still had to get common denominators. So when I look at the two of these, I notice I have a 3 on the bottom and a 6 on the bottom. And I know 3 is a multiple of 6. So I'm going to leave this fraction alone and just change this fraction. So to get a 6 on the bottom, I'm going to multiply times 2. which means on the top, I'm going to go times 2, and 2 times 2 is 4. So now I have 13 and 4, 6, which means if I add up my whole numbers, 2 plus 13 would give me 15. And then since I have common denominators, my denominator is going to stay a 6, and 1 plus 4 would give me 5, or 15 and 5 6. Right? So hopefully that made a little sense to you. It's going to be worked out in your book on page 354 as well, so you can always look back. But what I'm going to ask you to do is right below 354 example 3, there is a check problem. So I'm going to ask the sub if she would please pause the video and allow you time to work on the check on page 354. Okay, so let's talk about that check problem that you just discussed with your partners. So when I'm solving for p minus 3/4 equals 4 2/5, I think, here's what I know about subtraction. Whole minus a part leaves me with a part. So if I put back my two parts together, I'm going to end up with my whole, or in this case, my variable p. So what I want to do is get p by itself. So I'm going to add my variables together, or add my parts together. So if I add 3/4 on that side, I just have the variable p. And if I add 3/4 on this side, again, I remember to add fractions, I need common denominators. So 5 and 4, well, 4 is not a variable of 5, like in the example, and 5 is not a variable of 4. So I have to find some number that both 5 and 4 will go into. So the easiest one that I can think of is 20. So I am going to change 4 2/5 into 4 and something over 20. And I'm going to change plus 3/4 into something over 20. So to get from 5 to 20, I'm going to do a times 4, which means I need a times 4 here, which would give me 8. 4 and 8 over 20. Again, to get from 4 to 20, I'm going to do a times 5. So to do the same thing on the top, that equality, I'm going to end up with a 15. Now in this case, when I add my wholes, I only had 4. The bottom fraction didn't have any wholes. So 4 plus nothing is just 4. My denominator is going to stay at 20. And I'm going to add 8 plus 15, which is going to give me a value of 23. Now, when I look at this answer, I notice a couple of things. One, my numerator is bigger than my denominator, so I'm going to have to make some changes. So I can get 20 into 23 one whole time, which is going to change my 4 to a 5. So what I did is I took 23 and I divided it by 20, and it went one whole time, which was just 20. And it left me with 3. So I have 1 3/20. So that 1 gets added onto my whole number, which is 4. That became a 5. And left over is 3/20. So I think, can I simplify this anymore? And the answer is no. The only way I could simplify this is if this was a 21, because we know 3 times 7 would give us 21. So this is the simplest form that I can come up with. 5 and 3 over 20 would be the value of P. Okay, you're going to have an exit ticket that looks like this, and you're going to also have some problems on your worksheet that look like this to complete. So if you have a question, please ask the sub to pause the video and do some more practice. All right, so we have one more thing to take care of, and that's the apply that you're going to find on the neighbor page. So let's find page 355 and look at the apply question here. So my apply question says this: Tyson had $302.87 in his savings account after he withdrew money to go shopping. He spent the amount shown in the table, and he had $18.25 remaining. Use an equation to find out how much Tyson originally had in his savings account. All right, so here's what I've got to figure out. One, what is this problem asking me? So it said, how much does Tyson have in his original savings account? That's what I don't know, and I'm trying to figure out. So that is going to represent my variable, and I'm just going to pick T. I don't know what Tyson started with. Ooh, that also gives me another clue. Started with. That means that's going to be the beginning of my equation. So I don't know what Tyson started with. But here's what my problem told me. When he finished, this is what he had in his savings account. So I know at the very, very end here, this has to equal $302.87. Okay? Now as I look, it says he spent the amount shown and he had $18.25 remaining to spend. So thinking about that, spending means subtracting, right? So if I look here, he's going to subtract this amount from whatever he started with.
I'm sorry.
And then he's going to also subtract this amount that he spent on clothes. So we're going to subtract $95.21. And then we're also going to subtract the price he paid for the soccer ball, which was $23.75. But now let's think about, what are we going to do with this $18.25? So think for a minute. Tyson started with some money. He spent money. He spent some more money. He spent some more money. He has some money left over. And here's what he has in his savings account. Okay? So what I'm missing is, what do I do in that leftover money spot? Right? Because Tyson has already withdrew the money, that means I'm going to take that value away. So into my problem, I'm going to need to subtract 18.25. So I have what Tyson started with. I have everything that he subtracted, and I have what it equals. Right? Now think for a minute, how would you go about solving my equation? Right? If you're thinking, well, I would add each of these back on. That would be a great way to do it. And that is one way, because that's what we talked about. we've got to get this $42.79 to the other side, because here's what we know. This is his starting amount, and these are all of his parts that we've got to put together to get back to the top, okay, to get back to what he started with. So one way to do it would be to add that value here, add this value over here, add this value, and add this value. Did we think of another way? If you were thinking, well, I would put all these values together to see exactly how much you spent and then add it to the other side, that would work too. There's no right or wrong way to complete this part of the problem, as long as you're solving for t by adding our parts back over together, okay? So I'm going to work this out by adding each one over. So the first thing I'm going to do is add 42.79, which means that's gone, but it's got to come over here. 42.79. So I add those together. And the answer that I'm going to come up with, let's see. So that's 15, 16, 5, 4, 3. Then again, I need to add this value to get rid of it. So I'm adding it. It's gone. So I add it over here. 95.21. Add it over to this side. So I got 7, 8, drop my decimal, 10. So I carry the 1. That would make 14. Carry my 1, which would give me 4. Now I'm going to add this value, which means that has disappeared on this side. But my part came back over here. Uh-oh. My decimals didn't line up, did they? Let me fix that. So remember, keep our decimals in line. 23.75. I'm going to add that over here just like I added it to this side to get rid of it. So we got 12, 15, 16. Carry my 1. Drop the decimal. 4. 4 plus 2 is 6. Then we got a 4. And I've got one last amount to add, that amount that he had left over from his shopping spree. So I'm going to add that 18. Again, keep your decimals lined up. We're adding decimals. 25. So let's see. 7, 8. Drop your decimal. 6, 7, 8 again. So what I found is we have $482.87 when we began our shopping. Okay, so T is going to equal, his savings account had $482 in it and 87 cents before he went shopping. So if you looked at it the second way and you said, I just would have put these values together that he added, again, that's an okay way to do it, because you would have added all these values up. So let me stick the 1825 in here. And when you added all of these values up, you could have found the total amount he spent. Okay, so let's see if we get the same answer that way. So let's see, 14, 15, that would be 20. So carry my 2, 2, 4, 11, 13. Ooh, 13 plus 7 would be 20 again. Put down the 0, carry my 2. So I have 10, 12, 17, 18, 19, 20. We could keep getting 20 for an answer here. Carry my 2 again. So 2 plus 1 is 3, plus 4 makes 7, plus 9 makes 16, and 2 more makes 18. So here's another way to look at this problem, is to say that Tyson spent $180. So if you're thinking of your equation that way, you're thinking, well, Tyson had some money in his savings account. He spent or took out $180, and that left him with the same amount that it told me, $302.87. Which meant instead of adding each of those over and making that really long subtraction problem, instead, all I had to do is add these two parts together. So I got rid of the 180 to figure out what $302.87 plus 180 is. All right. So I add those back up. Uh-oh, I didn't need to carry my 1 there, did I? My fault. So that's just 8. And I arrived at the same answer as I did the first time. He has $482.87 in his savings account before he goes shopping, right? So that problem just has multiple steps. It's the same idea, thinking about my value being my whole that I start with and subtracting parts or subtracting one large part, okay? So there is a check just like this problem on page 356. So I'm going to ask the sub to pause the video, and I would like you to work with your table on this check to see what you get for an answer. Go ahead and pause the video. All right, so let's see what you got for an answer. So it says on my check, Nina used 12 1/3 yards of ribbon to make hair bows and 5 yards of ribbon to wrap gifts. She has 17 2/3 yards of ribbon left. Use the subtraction equation to find out how many yards of ribbon she had to start with. So again, when I begin this problem, I think, what am I trying to solve? So it asks me to find out, using a subtraction equation, how many yards of ribbon did she have to start with? So I'm going to let that value be R. So I'm trying to figure out, what does R equal? So I know she started with ribbon. So thinking more about this problem, I know she used 2 1/3 yards of ribbon to make hair bows. I also know that she used 5 yards of ribbon to wrap gifts. And I know that at the end, she had 17 2/3 left. So this is the subtraction equation that I'm going to use to find out how much ribbon does she have left. So the last problem that we worked out, we worked it 2 different ways. We decided we could either combine the amount she used and and add that value, or I could go piece by piece. So let's look at it piece by piece first, and then we'll put them together. All right, so I want to get R by itself. So I'm going to get rid of 12 1/3 by adding it because I'm subtracting. I'm going to put my pieces back together. So I'm going to add 12 1/3. Ooh, I like it when I go to add my fractions and my denominators are already the same. So I have 17 whole and 12 whole. So that just gives me 29 wholes. and I have 3 over 3. What does it mean when my numerator and denominator are the same? If you're thinking that's 1, you are correct. So that's just equal to 30 because this is the value of 1. So I have 29 plus 1 more, which just gives me my 30. And now I need to get rid of this 5 over here. So I'm going to add 5 to my minus 5. That'll get me back to 0, and I'll get to figure out what R equals. So I have 30, and I'm going to add 5, which means I now have 35. So R equals 35. One way that your group could have solved. A second way your group could have solved my subtraction equation, R minus 12 1/3 minus 5 equals 17 2/3. You could have said, well, I'm going to go ahead and combine all of these values she used. So if I combine 12 1/3 plus 5, no fraction, I'm going to get 17 1/3. So that leaves me with an equation that looks like this. R minus 17 1/3 equals 17 2/3, which means to get R by itself, I got to add 17 1/3, cancels out. R equals plus 17 1/3. Well, let's see. 17 plus 17 will give me 34. And then denominator's the same, so there's 3 on the bottom. 2 plus 1 is 3. We just said if the numerator and the denominator match, that's a value of 1. So I have 34 plus 1 more makes 35. So no matter which way my group chose to solve it, I found that R equals 35. Nina started with 35 yards of ribbon. All right. So you are going to work on your assignment now. Before you begin your assignment, your sub is going to give you an exit ticket. Your exit ticket resembles example 3. If you need to look back at example 3 for help, please do so. But I'm going to ask you to complete your exit ticket over example 3 first, and then begin working on the assignment that the sub displays on the board. This is our last part of lesson 3. So today will be a term end day. If there is a problem that you are struggling on, do your very best to answer it. And that is a problem that we can go over tomorrow before we begin lesson 4. I hope you guys have a great day. Remember to use your very best manners as a sub is here, and I will see you guys tomorrow.